In this video, I'm trying to show how to transpose a radical function, that is the square root function. So let's start with the parent function. Y is just a square root of x, and you can see clearly the graph of this is a square root function. It starts, the domain is 0, and all grade 0 greater than equal to 0, and the range is from 0 to infinity. So this is the main graph of understanding. I'm gonna take first do the horizontal shift. So let's see if I now here there are uh, variables a, b, c, h, and k. So how these letters affect the graph? So I'm going to start with the basic. First one is, what if it was square root of x? So let's do the vertical shift. Now what is the vertical shift is, if I put a plus 2, okay, this is the original. So the next one I'm going to do is square root of x, and then outside plus 2. Then I'm going to plus 2, and you can clearly see the graph shift. So this is the main starting point. It shifts two places up because of that plus 2. And if I put minus 2, y equals square root of x. And let's put minus 3. And there you go. This graph, the original graph, the blue graph, shifts three places down. So the number by itself, the k, so how does this k affect is either the graph, the whole entire graph shifts up two places or three places down. That's all we learned in this so far. This is called the vertical shift. Now I'm going to take off this and see how does what happens if I change this h. So let's take, we'll put b is 1, a is 1, and k is 0. So no more horizontal, no more vertical shifts. I'll take this off. And let's start with y equals square root of this and x, and inside I'm going to write minus 3. And one can see that the graph has shifted three places to the right. How do we know this is really true? So this is 3 comma 0, and if you plug in x is 3 here, 3 minus 3 is 0. So that means this point, which was right here at the origin, has shifted 1, 2, 3 places to the right. That's all it is. I can write another one with plus and see how that affects square root of x, and this time I'll put plus 2. Let's see, and there you go. So the graph has shifted 2 units to the left side. So in other words, so this one is x minus 3. That means the main thing is this 3. So 3 positive, it moves to the right, and this basically is I can write it as minus of minus 2. See, so it means x minus of plus minus 2, that means the graph shifts two places to the left. So that means when you plug this x equals this minus 2, if I plug here, then it is minus 2, and then this 2 negative makes it positive. So you get 0, and that's correct. So now I will take this off. Just remember, if there is a plus 2, it basically means the graph shifts at minus 2, two places to the left. Hope that helps. So this h, so here I'm gonna write, maybe we could write even h. This h is positive, which is 3 right here, and the graph shifts to the right. And this h, when it is negative, even though it looks like 2, but then it is minus, and then again I write minus this, so it moves two places to the left, that is at minus 2. So hope this helps to understand the meaning of horizontal shift. So let's check next is about, let me take this two off and then see what about graph if I put a y equals minus, And you can see minus means all the y coordinates they will change and the graph will shift downward. The same thing, let me press and hold and put some other color. And there you go, see. So whenever there's a minus outside, this minus, what does that minus do? It reflects the original graph, the blue graph, over the x-axis. And if I take this off and put minus inside, the graph reflects over the y-axis. So again, I repeat. So this is y equals minus square root of x. So there are three graphs here. See? So the blue graph, when it reflects over the x-axis, is where you have to have a minus outside. But if the minus is inside, then it reflects over the y-axis. And you can see the domain changes instead of 0 to infinity. This becomes minus infinity and until 0 here. So one need to be very careful here. The next is, so now that we know reflection over the x-axis and reflection over the y-axis, now this orange color, instead of y equals square root of minus, let me put minus outside and see how does placing minus, how does the graph look like? And you can see this graph, the first part is you can use this minus to say the original graph. Let's see if this is the graph. This graph, because of this minus, it reflects over the x-axis, and in the inside minus, what it does is it reflects over the y-axis. So there are two things, two transformation occurring. One is reflect over the x-axis and then reflect over the y-axis. So that's what that means. Or in other words, also, it's the graph is reflects over the point. So origin. So if this is the point origin, so the blue graph reflects over the point origin, and you can see this blue graph. The whole thing reflects. So if I want to show one point here, let me see if I can do that. So what do I mean here is if this is the point, see this point. Mhm. Okay, let me. So if this is the point, which is 4 and 2, because square root of 4 is 2, right? So then the other point, that this point, which is negative 4 minus 2, is the reflection. See this part? So if I try to join a vector here from 0 to here, so the other one is a reflection. Every point is getting reflected over the origin, this one. So that's all that means is, so uh, so the symmetric, this is also called symmetric about the origin. Symmetric about the origin. So that's what is, if you put two minus. Okay, let me take this two off, and now let's see what is the meaning of vertical stretch. So the reason I'm trying to show this is because we can apply this to the trigonometric functions, because the idea is being extended to trig functions. So here, if I put 2 and the square root of it, and put an x. So what does this mean is, you can see, and I can put x equals 1, how x equals x equals 1, and you can see the point. So when x is 1, the first is 1 comma 1, but the second one is, so the x coordinate stays the same, the y coordinate change from 1 to 2. So basically, because there is a here, the a is 2, so the a which I show right here is 2, and that's why all the y coordinates get multiplied by 2. The x coordinate stays the same. So this is called vertical stretch in this case, because this 2 is greater than, let's take another one with x equals 1/3 of, sorry, y equals 1/3 of root x. And see the graph, the red color. This was the original 1, 1, right? But because of this 2, whenever it is greater than 1, the y coordinates is multiplied, so it gets stretched. So this point went stretched, but the other one, 1/3, you see, the red one, look at this part. This is 0.33. That means it was 1, the y coordinate. Now it compressed, so there is a shrink of the graph. The blue graph shrunk by a scale factor of 1/3. In this case, it is 1/3, 0.333, like that. So understand that anything point outside this decide whether there is a vertical stretch or whether there is a vertical compression or there is if there is a shrink. So either you use the word vertical stretch or vertical shrink or compression. So in this example, I give one. So the goal here is to just understand that the y coordinates, so this was the original 1, but the y coordinate gets multiplied by this 2. If I put it 3, then see that it goes up. If I put it 4, then it still goes straight. So that's the vertical stretch there. And if I put instead of 1/3, I put 1/4, then there's more compression. I can make it still more smaller, more compressed. So you just kind of multiply the y coordinate. Now let's move, let's check, take this off. Let me take this off. And this time we are going to check how does, let me put a 9 there. I'm going to put a 9. If I put a 9 and see how the graph look like. Okay, so I'll pull this graph up. What did take place down here? So square root of 9, this basically means also, I want to write here x, this x divide by 1/9. So we can write this square root of 9x as square root of x divided by half, just to show that this 1/9 that I showed here, the whole 1/9, let me see, I can put it inside. Yeah, this 1/9 is a fraction. Can you see this is a fraction? So how does the point, let me see, x equals, let's see, this time I'm putting here x equals 9 and see what. So in the beginning, when it is 9, this part, so this is 9, right? So 9 is 3. So that's the original one. Now what's happening here is this one, this 9, 3, this point which you see, it shrinks or compresses horizontally to a point right here. I'm going to put there at x equals 1 and see how it is. Okay. So that the point which is right here, okay, or I'm going to write y equals, let's see, 3. Let me take this off. Y equals 3. There you go. And this y equals 3. The y coordinate, both point is the same. This point has shifted 9 places to the left. Or it's like you're dividing. This 9 is divided by the 1/9. And that's why. So just whatever this fraction which you see, the denominator, that's multiplied to the x coordinate 9. So it is 1/9 of 9 is the 1. So basically, of course, it's just if there is a 9 here, what we do is you just multiply the x coordinate, this x coordinate, 9 divided by 9 is 1. But the right way to do is write down 1/9 of that point. So this is how there is a horizontal compression by scale factor of 1/9. So each of the x coordinate is shrunk like this. Then also if you want to say y equals 2, let's see if I put y equals 2 here. See, so this point was 4, 2, and now it is 1/9 of 4. So 1/9 of 4 is 0.444. So let me put more point. If I write y equals 3, or I can write y equals 4. So now look at this. This point is 16 is 4. Square root of 16 we do know 4. And 1/9 of 16 is right here. That's what it means. The y coordinate stays the same. This point was 9, 3, but now it is 1, 3 because 1/9 of 9 is 1. This point was 4, 2, and now, so every point on the blue graph, the parent graph of the square function, gets compressed by that scale factor 1/9. So the x coordinate is multiplied by 1/9. But remember, the over here we multiply the outside whenever there's outside letter. This one that's kind of greater than one vertical stretch, less than one vertical shrink. The same thing here. This is a fraction less than one, so there is a horizontal compression. And one more thing we'll see is, let me take this off. And what if I had a fraction here? Like put half here, divided by 2 here. See? So, so if it was half of x, this is already over 2. So this part is 2. See? So there's already 2 there. So what you're doing is so you're going to multiply 2 to the x coordinate. So the original one is the blue graph, and now let's put y equals 3 there. Or let's take an easy one, y equals 2. Look at the point. This was the original point, right? 4, 2. And now, because the down number is 2, so 2 is greater than 1, so there has to be a horizontal stretch. So this 2, 4, 2, which is right here, this 4, now is multiplied by 2. So it becomes 8. So beautiful this is. Or if I put y equals 1, so this original is 1, 1. This one, which you see the x coordinate is multiplied by 2. And if I put another last one, y equals 3, and you can see, okay, I'll have to pull this graph a little to the left to check the point. So this point, 9, 3 becomes 18, 3, see? So the x coordinate is multiplied by 3. This x coordinate 4, which you see here, is multiplied by 2, get 8. X coordinate 1, which was here, multiplied by 2, you get this point. So this, sorry, it shows other way around, but this point is here. So basically, this video I'm trying to make is just to understand the difference between a vertical stretch, compression, and horizontal stretch and compression. Hope this video helps just to understand why we multiply by the scale factor. Like in this case, it was half. It is 2. So because x divided by 2, that's the 2 you multiply. But if it is 9, if it was 9, then you have to make it down as 1 divided by 9. And that 1/9 is multiplied to the x coordinate to compress it. Hope that helps. So next video, I'm going to show how are we going to use this for, how are we going to extend this idea to let's see, if I have sine graph. So how does sine of x, and how it's the same idea. See, if you multiply 2 gets stretched by 3. So that's what I'm going to do in the next video. So stay tuned, keep watching. More videos will come to clear the concept. Thank you so much.